Hey folks, well, we took a look at the use of libraries and the use of functions, and so what I want to do for this session is just to practice a little bit with a couple of them. So we'll do a little bit of practicing with some stuff from CC we'll do a little bit of practicing with some stuff from CMath, and just see how we go. So there's the plan. I'm just going to kind of walk through the creation of some programs and yeah, babble as we go. All right, so let's start off with, how about a program where we'll get somebody to enter their initials. So what I'm going to do here is, again, I'm going to start off with a little bit of a description as to what this program is going to do. So let's say a program to get the user to enter their initials. Let's say their given name, or their given name and family name. Then we'll compute and display the uppercase equivalent. Blah, uppercase equivalent. So for this, what are we going to need? We're going to, let's say we'll use, let's use IOStream this time. We've been using the csci.viu.ca a lot lately, so let's try IOStream, and we're going to, again, specify that we're using the standard namespace. And so we'll use cout and cin. We won't do anything much in the way of formatting, but this time around, what we're going to do is get them to enter their initials. We'll prompt them, we'll read it in, we'll figure out the uppercase version and display it. But to figure out that uppercase version, we'll use some routines from that cc_type library that we talked about. So let's hash include cc_type as well. And so again, what I'm going to do here is just look at, let's have this as our program description. And then maybe let's come up with a design. So again, this is just going to be our preliminary idea of what our solution is going to look like. So we'll prompt the user for their initials. We'll declare variables to store what they enter. We'll compute the uppercase equivalent. So we're also going to need variables to store the uppercase equivalent. So we'll declare variables to store the uppercase equivalent. So compute the prompt the user for their initials. We'll declare some variables. We'll read in the user input to our variables. Here, let's maybe do it this way. So we'll prompt the user, have some variables to store what they type in, read what they type into our variables. We'll declare some variables for the uppercase equivalents. We'll compute and store the uppercase equivalents, and then we'll display the results. Something along those lines. So again, I'm just sitting down, before I start coding, I'm going to think about what steps I'm going to go through, and now I can work through the process of actually creating the program step by step. And again, I'm going to follow that kind of incremental development process, where we'll just do one little step at a time. So first off, my first version might just be to have the printf to get them to enter their initials. So please enter the initial for your given name. Oops, I said I was going to use cout and cin, didn't I? How about please enter the initial for your given name. And I'm going to throw an andl in here, just so we can play with that a little bit. So we'll just give them a prompt. And let's try compiling that just to see if we're on the right track so far. So g++ initials.cpp-o initials, and I'm going to turn on my warnings wall and extra for all the warnings and the extras. Let's see. So, looks like it compiled okay. And let's try running the beast. So, it gave me the prompt. Again, we haven't done anything beyond that. We haven't actually read anything in. We haven't treated variables or anything like that. But so far, so good. So, we'll go through and try some compilation here. Or try some expansion on this. Let's see. Let's declare our variables. So we want character variables to hold individual characters of input. So I'm going to have one for, let's say the user given and the user family name. And I'm going to have versions for the final given and final family initial. So in those first two will be what the user types in, and the second two will be after I've converted them to uppercase. Yeah. Oops, I'm off the bottom of the screen here, aren't I? All right, let's see. So I've declared my variables. Let's try using cin to read that first one. So we'll do a cin into user given. Maybe just to have things grouped a little more nicely, I'm going to rearrange this a bit. And I'll declare my variables first, and then do the prompt and the read. And then I'll do the same thing for the family name. So I'm just going to copy and paste this and say, okay, please enter the initial for your family name. And then we'll read that in. And that might be a good place to leave it for the moment, just to see if our input and output works okay. So let's try compiling again. And it's warning me that I've put values in those two variables, but I haven't done anything with them. And two of the variables I haven't done anything with at all. No, actually, I guess it's just warning me about the two unused variables. But that'll go away as soon as I actually use them for something. So let's see here. How about, now that we've got them, let's do our, so let's throw in a comment here to say get the initials from the user. Let's throw in one to determine the uppercase equivalent. And so what we're going to use from that CC type routine is one called toUpper, where we give it the original and it gives us back the uppercase version. So I want to put the new one in, say, final given. And so I want to call this toUpper routine, and I want to pass it whatever they typed in. So figure out the uppercase equivalent of whatever they typed in for the given initial, and then I'll do the same thing for the other one. toUpper user family. So in theory, this should go off, find the toUpper routine, figure out what the equivalent uppercase values are, and store those. So let's try that compilation one more time. Let's see, and so, oops, sorry about that. Let's see that one more time. So this is, now it's telling me that I've stored values in the variables, but I've never done anything with it afterwards. So did I really want to bother computing that? But we'll use that in just a second. So those warning, I guess we can give this a try as well. So let's try running this. So please enter the initial for your given name, so I'll say D. Please enter the initial for your family name, so I'll say W. And it's presumably going off and doing the conversion, but we haven't displayed anything yet. So let's try and actually display the results now. So let's say we'll display the results. So let's use cout again and say your initials are, and then we'll display the final given, and maybe a dot. And then we'll do the same thing for, let's throw in a, should we put them just together? Yeah, we'll put them together. So it'll come out as my first initial, a dot, my second initial, a dot, and then we'll throw in a new line using indel. All right, so this should give us the results we're looking for, hopefully, and no compiler warnings anymore. And so let's try running the beast. So let's say I throw in a D, I throw in a W, and it gets my DW. Hey, woohoo! So just in terms of the way toUpper actually works, so it figures out the uppercase equivalent and gives that back. If it's already uppercase, then you just get the same thing back. So if I actually entered, let's say, uppercase D and lowercase w, it'll, again, convert, leave the one of them at uppercase and convert the other one. If I was to go through and run it and give it something that was irrelevant, it just gives back the same thing. So it doesn't try and figure out an uppercase version of 1 or 2 or an uppercase version of an exclamation mark or a question mark or something like that. Right? It just gives those back. All right. So again, it's our kind of usual cycle. We go through, we declare the libraries that we need, we declare the variables we need, prompt the user, do whatever computation we need to do, and display results. Pretty typical sequence. So let's try one more. Let's try one with the CMath library. So how about we try one that's going to, we'll give it the 3 coefficients for a polynomial, and we'll get it to go off and compute the quadratic, or compute the roots of it. So apply the quadratic equation or something equally exciting. So how about we'll try this one as roots.cpp. And for this one, let's use printf and scanf this time around. So we'll use csci.viu. And we're going to need the CMath library for some of the routines we're going to come up with here. And I guess I should throw in my description. And then we'll throw in a design. And then we'll dive into writing the code. So we'll get the user to enter the 3 coefficients for, ax squared plus bx plus c, and compute the roots using the quadratic equation. All right, so that was our negative a plus or minus the square root of b squared minus 4ac all over 2a if the rusty recesses of my math memory is still correct. So we'll go off and compute these 2 roots. Now, we haven't got the ability to do much in the way of error checking yet. So when I'm doing this, I'm just going to make sure that I pick roots that will actually, or pick coefficients that will actually work out okay. So we'll fudge a little bit there. Very soon we'll get into talking about the techniques we can use to actually do error checking on whatever it is the user types in, so that we can compute appropriately when the root would be imaginary, or when there's only one root, or that kind of an idea. But for now, this is the idea. Maybe we'll throw one more step in there. Then display the roots, then get the user to enter a value for x, and compute and display, evaluate the polynomial for x. For their value of x. Let's give that a whirl. So this is what we want to do. So this one will be a slightly longer program, right? We've got a few more steps and a little bit more computation to work through here. So what do we want? This will be pretty much the same sort of a design as we've done so far. Let's say we'll declare variables for a, b, c, x, the two roots, and the result of the polynomial. And the result of evaluating the polynomial. Again, just thinking about the different data values I'm likely to need to store and making sure I've got those. Right, I'll prompt the user for the coefficients. I'll read and store the values. I'll compute and store the two roots. I'll display the roots. I'll prompt the user for x, a value for x. I'll read and store x. I'll compute and store the result of the polynomial. Now that I've got a and b and c and x, and I'll display, maybe I'll display the polynomial and the result. So something along those lines. So again, I'm just thinking about what kind of steps I need to go through, and then I can go through and actually turn this into code. So let's see about this. Let's go through and create our main. We'll create a couple of variables here. So I'm going to make these doubles. So let's have doubles for a, b, c, x. Let's have doubles for root 1, root 2, and the result of the polynomial. All right, so again, we'll go through and figure out what kind of storage we need, and then we'll go through, get the values from the user. For the polynomial, ax squared plus bx plus c, enter a value for a. And then I'm going to do my scanf to read it in. So this is a double, so it's LF, or long float, for the format string, and I want the value to go into A. And then I'll do the same sort of thing. Now enter a value for B, and we'll read it in. And maybe now enter a value for C, and we'll read it in. Now, again, we would, in reality, wind up doing some error checking around here to make sure that those were all valid values, that they actually entered numbers. But for now, we can't do that. So we'll just go ahead and hope for the best. So let's try compiling this. So we want to compile our roots.cpp. We'll put the executable, name the executable roots. I'll turn on my warning flags. And again, our warnings about unused variables because we haven't done anything with these things yet. But those warnings will disappear as soon as we actually do something with this. So if we try it out, so let's try our roots. So for the polynomial, enter a value for A. So let's say 5. Enter a value for B. Let's say 10. Enter a value for C. Let's say 6. Oops, sorry, this is disappearing off the bottom of the screen, isn't it? So at the moment, it's not actually doing anything for us yet, but it does appear to be at least attempting to prompt and read. So let's try this some more. What have we got? So we've got the variables read in. So now let's compute first root. Okay, so this will be a little bit more fun. We want, again, negative b. Did I actually write that correctly up there? It suddenly just dawned on me that I said negative a up there. Negative b plus or minus the square root of b squared minus 4ac. So, again, this is our attempt at the computation. We want to store the result in root 1. And I want to compute, let's see, negative b. And I'm going to compute the plus version first, plus the square root of, and we want b squared minus 4ac. So b squared I can get with the power of b to 2. Right? So there I've got my b squared minus 4 times a times c. So what I'm doing here is doing this computation of the part inside the square root symbol, if you like, and passing all of that, right, the result of that, going off and computing b squared minus 4ac, and I'm passing that as my parameter to square root. Square root is then returning it, and we're doing our, adding it to negative b. And then we want to take all of this and divide it by 2a. So I'm going to throw brackets around that to make sure that we actually get the computation right, and I want to divide it by 2 times a. So, assuming I've done my math right, this is actually going through and getting our first root computed. Again, negative b plus the square root of b squared minus 4ac, and then all over 2a. And again, if this felt a little too ugly to go through and write in this format, you could break these steps up. We're going to use the power, we're going to use b squared minus 4ac again in a moment, or the square root of b squared minus 4ac again in a moment. It might have made sense to calculate that and store it in a variable and just use that variable twice. But hopefully, if we go through and print out, first root is, and let's say root 1. So we'll try printing that out. And let's just give this a quick compile and see if it works. It's still complaining about variables we haven't used yet, but that's okay because we haven't got to that part of the program yet. But it does seem to be attempting things. So let's try our roots. Let's say, 2 for A, and 10 for B, and 1 for C. Again, just making up numbers here, but so this is going to be negative b plus or minus, or so negative 10 plus the square root of 10 squared minus 2, something like that, minus 8, I guess. Let's see how we go here. So it goes off and computes first root. I have no idea if that number is actually right or not. Sit down with a calculator later and check it out. But again, we've got kind of, assuming our computation is actually correct, we're working our way along the right track here. So let's assume for the moment that that computation is correct, and I should go back and check that. So we'll compute the second root. Now this one's the same idea, it's just that it's negative b minus the square root of b squared, blah, 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 blah. So we should just have to, you know, cut and paste that and turn it into a minus, and we should get the second root. And we want to store this in root 2. Oops, and we want to display root 2. Dangers of cutting and pasting is when you forget to update something. All right, so let's try our compilation again. And it seems to be okay there so far. Again, it's still giving me the warnings about the couple of things I haven't used yet because I haven't tried entering a value of x and evaluating the polynomial. But we can see if our roots work. So how about if we try 8 for A, let's say 5 for B, 0.5 for C. And if I've got this right, it should come out to negative 5/16 and negative 11/16 for the two roots. Negative 1/2 and negative 1. So is my computation incorrect? I bet my computation's incorrect. My mental version of what it should come out to. So if we just give that a quick check mentally, so we want negative b, let's say plus or minus the square root of b squared minus 4ac all over 2a. So the b squared minus 4ac should be 8 squared, so that's 64, minus 4 times, oops, pardon me, no, I'm messing up already. So my b squared should be the 5 squared, so that should be negative 5 plus or minus the square root of 5 squared minus 4 times 8 times 1/2 all over 2 times 8. Good grief. So negative 5 plus or minus the square root of 25 minus 16, which should be the square root of 9 all over 2 times 8, which should be negative 5 plus or minus 3 over 16. So that should be negative 8 over 16, or negative 2 over 16, which should be 1/8, negative 1/2, or negative 1/8. Hey, okay, so the program's actually correct. My mental math had been wrong. But again, we can go through and anytime you're doing computations, you want to stop and, again, do your math just to check if your computations are actually coming out correctly. But that does seem to be the case here. So now that we've got that chunk down and working, our last piece was that we wanted to get a value for x and evaluate the polynomial. So let's, again, ask the user, enter a value for x, and we'll scan that in. So another %lf going into x this time. And now we want to compute the result is equal to ax squared, so a times x, or you could do power of x2, plus b times x plus c. And then we'll do our final result. And so now we want to print we want to print the %lf for a. We want to print x. And I'm going to use the little hat thingy to indicate the squared. %lf squared, so that's going to be our x squared, plus percent LF for the B, percent LF for the X, plus percent LF for the C equals percent LF for the result. Blah. Okay, so our format string has got the A, the X, the B, the X, and the C, and the result. So A, X, B, X, C, result. Let's see how that goes. Yeah, well, no more complaints. So let's try the same thing. We'll try 8 and 5 and 0.5 for our 3 roots. And then for X, let's try, actually let's try one of the roots we came up with. Let's try negative 0.5. Oops, sorry, that went off the bottom of the screen. So I entered 0.5 and it came up and said, okay, 8, so the A times negative 0.5 squared plus 5, the B times negative 0.5 plus the C, 0.5 comes out to 0, which it should because that's supposed to be one of the roots. Hey, all right. Now, we could obviously fancy up our printf so that this looked a little bit nicer here. Actually, there's a format character that we haven't taken a look at that we'll show you here. So there is one called %G that drops all those trailing zeros. Might have mentioned it earlier this term, but I don't think so. So again, we can do %Gs, and we'll try compiling again, and we'll try running it again. And again, we'll give it our, let's say 8, 5, 0.5. Again, this part hasn't been using the %Gs yet. Prints out the 2 roots. We'll enter a value for X, so let's say negative 0.5. And this time it comes out and says, okay, 8 times negative 0.5 squared plus 5 minus, or plus 5, and again, I should throw in some brackets or multiplication symbols or something to make this a little bit more readable, but we have got the right idea. Let's do that just to make our output a little clearer here. So let's say G times, so the A times X squared plus B times X plus C. Compile, run, and again, I'm just going to stick with the same values for the moment. It gives us our 2 roots. We'll enter, a value for X, and we get, again, hopefully a little bit, A times negative 0.5 squared plus 5 times negative 0.5 plus 0.5 comes out with a 0. So, woohoo! Again, this is the kind of cycle that we'll wind up going through. Is given a description of the problem we want to solve, think about the design that we're going to use, think about the libraries we're going to use, think about the variables we're going to use, and then just go through step by step, incrementing, compiling and testing, incrementing, compiling and testing, until hopefully eventually it does what we want. Okay, that is a good place to leave it for now.